Welcome back, mathematicians. In this video, we are going to learn about the inverse sine function. So a little background about inverse functions. In order for a function to have an inverse, it must be a one-to-one function. We can see that the sine function actually is not one-to-one. It fails the horizontal line test. As a result, what we will do is narrow the domain of the sine function to be from negative pi over 2 to pi over 2. Inclusive. The range, however, will remain the same as negative 1 to 1. So you can see on the graph, we are only going to be looking at this blue section of the curve. And again, this is inclusive, meaning it's including the endpoints of negative pi over 2 comma negative 1 and pi over 2 comma positive 1. As a result, the definition of the inverse sine function is that y is equal to the inverse sine of x if and only if x is equal to the sine of y, where negative 1 is less than or equal to x, which is less than or equal to 1, meaning x needs to be between negative 1 and 1 inclusive, and y needs to be between negative pi over 2 and positive pi over 2 inclusive. We will now use that information in order to find the exact value of each of these inverse sine functions. So first, it's important to understand what the input of the inverse sine functions represents. It's the ratio. And so the output for the inverse sine function should be an angle. I like to use theta to represent that output for the inverse sine function as a reminder that what I'm really trying to find is an angle. So what I'm going to do here is take the sine of both sides, and as a result, what I end up getting is negative 1 is equal to the sine of theta. But keep in mind that theta must be greater than or equal to negative pi over 2, but less than or equal to positive pi over 2. So when I go ahead and draw a picture of this scenario, I have my initial side on the positive x-axis. Because of the fact that this ratio is equal to negative 1, and remember that sine of theta is equal to y over r, I know that the terminal side should be on the negative y-axis. Because it's on an axis, I'm going to go ahead and use the unit circle to solve this problem. Where the unit circle intersects the negative y-axis is going to be 0, negative 1, and the angle that represents this would be 3 pi over 2. However, theta must be greater than or equal to negative pi over 2, but less than pi over 2. So 3 pi over 2 is not within that range. So what I need to do instead is use the clockwise rotation or coterminal angle, which would be negative pi over 2. So for our problem, theta will be equal to negative pi over 2. So again, the output for these inverse sine functions are going to be the angle, whereas the input is the ratio. Let's now go to inverse sine of negative square root of 3 over 2. So again, I'm going to let this equal to theta. I'm then going to evaluate sine on both sides. So I will get negative square root of 3 over 2 is equal to the sine of theta. So what I'm really trying to find is the angle that when evaluated for sine is equal to the ratio of negative square root of 3 over 2, but I need to keep in mind that theta has to be greater than or equal to negative pi over 2 and less than or equal to positive pi over 2. Now that negative pi over 2 to positive pi over 2 really restricts the terminal side to be either in quadrant number 1 or quadrant number 4. I have my initial side on the positive x-axis. Because the ratio is negative, I know that this terminal side will be in quadrant number 4. This is where you would then go to your unit circle, if you are using a unit circle, and try to find the y-coordinate that is in quadrant number 4 that has a value of negative square root of 3 over 2. Or you can go ahead and create your triangle and recognize that the y-coordinate would be negative square root of 3. The hypotenuse or radius is 2, which means your adjacent side is positive 1. That means this reference angle here is pi over 3. And because we need clockwise rotation, since it is in quadrant number 4, we can see that theta will be equal to negative pi over 3. Again, we would not choose the coterminal angle, which would be 5 pi over 3. We would have to choose the negative angle because of the fact we have to have the angle from negative pi over 2 to positive pi over 2. All right, guys, good luck.